We'll now take a closer look at RC circuits. So we want to try to figure out the voltage for the RC circuits. Kirchhoff's voltage law gives us that this is going to be equal to the voltage across the resistor plus the voltage across the capacitor. And we had formulas for each of these. This is equivalent to Ri plus Q over C. For these, we need an additional piece of information that the capacitor current is the rate of change of its charge. So I is equal to dq dt. Substituting this in gives us that R times dq dt plus Q over C is equal to E. So let's look at an example for this. Let's suppose a capacitor of C farads holds an initial charge of Q coulombs. To alter the charge, a constant voltage source of V volts is applied through a resistance of R ohms. We want to describe the capacitor charge for t greater than 0. Since we have a constant voltage source of V volts, we have that E of t is equal to V, so that's a constant. Sticking into the formula that we just talked about, we have R times dq dt plus Q over C is equal to V. So this is a linear differential equation. Moving it to standard form gives me dq dt plus 1 over RC Q is equal to V over R. Our integration factor is then mu is equal to e to the integral of 1 over RC dt, or e to the TRC. This gives us, once we use our formula for linear differential equations, e to the negative TRC times the integral of e to the TRC times V over R dt plus k. We then have, once we integrate and simplify a little bit, e to the negative TRC is equal to CV times e to the TRC plus k. We can go ahead and distribute this to simplify even more. When we do, we get CV plus k times e to the negative TRC. So now we might want to try to think about our initial condition. The original problem said that the initial charge was Q coulombs, so Q of 0 is equal to Q. Since e to the 0 is equal to 1, that tells us that Q is equal to CV plus k. Or equivalently, k is equal to Q minus CV. So we have our solution for the capacitor charge. Q of t is equal to CV plus Q minus CV times e to the negative TRC.